Welcome once again to integration by parts. This is integration part 4. We are done with part 3. The part 4 here is integration by parts. Basic foundation. Given u and v as a function of x, recall from our product rule in differentiation, we know that d ds into uv equals u dv dx plus v du dx. Multiplying both sides by ds, we have that d dx into uv multiplied by the x equals u dv dx dot dx plus v du ds dot dx. If you watch very well, this will cancel this will cancel. So that we are going to have d into uv equals u dv plus v du. Integrating both sides, dv du equals integral of u dv plus v du. uv equals integral of u dv plus integral of v du, making integral of v du subject of the formula will give us uv minus integral of u dv. This will now serve as a formula for integration by parts. Now let us start. There are integration by parts that you see with a logarithmic function such as evaluate x log exponent x ds. Care must be taken in handling something of this nature. The question is integral of x log exponent x dx. Let v dv equals s ds. Let u equals log exponent x. If dv equals x ds, when I integrate, I will have that v equals x squared all over 2. From foundation, recall that x raised to the power n plus 1 all over n plus 1 is the formula we'll be using. Now, if this is x, the power is what? 1, meaning x power 1 plus 1 all over 1 plus 1, which is equal to x raised to the power 2 all over 2. That is the integral part. Now, I want to handle the differentiation part of it. The u, the x equals 1 all over x. Reason, differentiation of logarithm is a fraction or an inverse. So if I cross multiply, I'm going to have the u, x du equals the x. So if I make the u subject of the formula, I will have the x all over x. Now, applying the rule, this general formula, u from this part equals log exponent s multiplied by v. V is s squared all over 2. Then minus integral of u dv. But you must be very, very careful. This formula you are seeing can also be uv equals integral of v du plus u dv. If I take u dv to this side, I'll have uv minus integral of u dv equals this here. If I decide to remove this, I will still have uv minus integral of u dv v du equals integral of u dv. So it depends on what you are solving, the nature of the question you are solving. If you are dealing with trig function, our dv cannot be the first one. It's going to take the second phase. But for logarithmic function, the v is taking the one that you can integrate easily. Because if I want to integrate log exponent x, it's a problem. But it's easy to integrate x. So you consider this while you solve. For that reason, uv log exponent x dot s squared all over 2 minus integral of v du, since I have du here. So what is my v? V equals s squared all over 2. Then what is my du? My du is what? ds all over s. That's dot the x all over x. That's what is going on, which will be equal to integral of u dv. From here, we'll have that s squared all over 2 log exponent s minus, if I cancel this, I will have a constant 1 all over 2 integral of s ds. Then I can easily integrate s to give us s squared all over 2 log exponent s minus s squared all over 4 plus c. I know you'll be wondering how it came about. This is half. So 1 over 2 multiplied by, if I integrate s squared, it means if I integrate s, that's s squared all over 2. So when I multiply, I'll have what? S squared all over 4. So that is the solution. S squared all over 2 log exponent x minus what? S squared all over 4 plus constant. As usual, you introduce because we don't have any range. Whenever you have range, you now apply uppercase minus lower case. Look at this. Integral of s exponent x, then ds. Let u equals x, dv equals exponent s ds. Let's see what happens. You also check du when du equals exponent x. When you do this, if one part is going to be difficult to integrate, that is when you take the difficult part as what? Just a single u or single v. But if it can be integrated, then you are using the u equals what? Exponent x. Now, if I say du equals exponent s ds, it means I am to integrate because it is assumed it has been differentiated. So when I integrate this, it means u equals what? Exponent s, because integration of exponent s is also exponent s. Now, differentiation, in this case here v equals s. I will not say dv the s equals what? 1, meaning the v equals to the s. Looking at this, check the right formula for you now. Is it transferring this to this and bringing this? This ended with what? The v. But the first one, we ended with who? With who? The u. That's why I switched. Because I told you that this can be either here and this coming this way, or this staying here, while this staying here. It depends on what you are integrating, the nature of the question. So, since we have the v, this formula will serve us very well. Meaning that integral of v du equals uv. So what is u? Exponent s dot v. So what is our v? X minus integral of u dv. What is our u? Exponent s. What is our dv? dv equals what? ds. Simple. So what do we have now? We have x exponent s minus, if I integrate, exponent s plus who? C. So you can see that exponent s is common, meaning exponent x into who? S minus 1 plus constant. Final answer. It's as easy as ABC, but you have to be very, very careful when you are dealing with integration by parts. It's just a name. When you take your time to go through it, follow the rule, you will get it exactly. Okay, let's take a look at integration of trigonometric functions. The trig part, you can see this s sine s, integrate s sine s, then integral of x sine x ds. I will select du equals sine s ds. Then v equals x. You can also say dv equals s sine s to give you whatever you have. It depends on what you want. Now, since I have du equals s ds, sine s ds, it means I am to integrate because it's assumed it has been differentiated already. Now, if I integrate sine s, integral of sine s ds equals cos s, meaning I am looking for single u. That's why integral of du equals integral of what? Sine s ds. Single u will come out here. That is u equals who? Cos s. You can see it. Now we have the integral part as cos this. Let us deal with this. The v, the s equals what? 1. Therefore, the v equals the s. As simple as ABC. Now we are set for the job. So what do you do? This equals uv minus integral of what? U dv. So what is our u? U equals cos s. What is our v? Our v is x, all right, minus integral of u. What is u? Cos s. Then the s, because the v equals what? The s. So I am replacing it there. This will give us s cos s minus integral of cos s is sine s. One integral of sine s is minus cos s. Attach the minus sign. So let us effect it here. Then plus constant. Our final answer would now be what? Minus, open the bracket, s cos s plus sine s plus c. That becomes the solution to that question. Minus, open bracket, s cos s plus sine s plus c. Let's check the next one. This is s squared cos s. I'm wiping this way. Integral of s squared cos s ds. As you say, let the u equals cos s ds, so that my v will be what? S squared. Okay. Then integral of the u, integral of cos s ds, u equals what? Sine s. dv ds equals 2x, so that dv equals 2s ds. This is what we have here. Now let's see if this thing will work out for us. Okay. It will work out for us. Let's fix it here now. uv sine x dot s squared minus integral of u, which is sine s dv. dv is what? 2s ds. If you watch this thing very well, it means it is still complex because we have sine s to be integrated. We also have 2s to be integrated. So, see what will happen now. S squared sine s minus, you're going to open a bracket, meaning a new formula is coming in again. From here, the u, the new du, let me just say the u prime equals to sine s ds, while the new v prime equals to 2s. So if I integrate the new one here now, I will have u prime equals to minus cos s. Differentiating the new v, that is the v prime ds equals 2. So I have to fix it again. Forget about the prime, it is still the v. Then this u prime is still this u. So I want to fix it in here now. That's our u is what? Minus cos s. Then v dot 2x, the main formula, minus integral of who? U dv. So from here now, what is dv? dv equals to ds. Okay? So u here is minus cos s dot dv. dv is what? 2 ds. I close the bracket. Just take time to watch it a little bit. Okay, now let me wipe here so I can conclude. This will give us s squared sine s. Leave this minus sign. Let us focus here. We'll have a bracket here. Minus cos s dot 2s, okay? Minus, if I integrate cos s, it will give me minus, it will give me sine s, but remember, it is carrying minus. This one is a constant, meaning I am factoring it outside here, the integral. Now let me integrate cos s, which is minus sine s, and minus minus is become what? Plus sine s, plus who? Constant. Now let's finalize. This is s squared sine s. I want to introduce my sign now. Minus minus is what? Plus 2s cos s. Plus minus plus minus 2 sine s plus who? Constant. This is the final answer to this question, final solution. So just look at it very well. It's not too difficult. All you need is to take your time and go through it. Other integrations. Other one that may still be bothering you, question of this nature. Let's see. It's not any question you see in integration, you use integration by parts. And it's not all the question you see, you use trapezoidal rule. It's not all the question you use substitution method. How do you know? Now let's see. If I have sine square s cos s ds. Now evaluate. If we want to use integration by part here, it's going to be a problem. Reason, we'll have a complex function here. So if this goes to du equals cos s ds, and this goes for v equals sine square s, you can see that sine square s is still complex, meaning we are going to invite chain rule. So as a result, it cannot be. Now let us test substitution. Let u equals sine s. Then du ds equals what? Cos s. We'll go back again. Integral of, recall you said u equals to sine s, meaning I'm seeing here as what? U squared now. I'm no longer saying sine s, sine square s. Dot who? Cos s. So from here now, this implies that the s equals who? Du all over cos s. So what is the s here now? The s equals what? Du all over cos s dot du all over cos s. Guys, see what's going on now? See, cancel, cancel. You have made it to become easier for you now. You have only what? U square du. It is easy to integrate now. And let us integrate. It's just like when you're integrating s squared. Remember, this will give us u power 3 all over 3 plus who? A constant. Now you have to recall that u equals to sine s. Now effecting it to get the final solution, we'll have that sine what? Cube all over 3 plus c. This is our solution to this question. You can also do it in the case of cos theta. Maybe if I say evaluate cos square s sine s. Just play with this. And let's take one more question from Jamb. Integrate integral of 4s cubed minus 7s squared plus 5x minus 6 all ds. It looks complex, but it doesn't really matter anything. Just separate this way, minus integral of 7s squared ds plus integral of 5s ds minus integral of 6 ds. So what you do with this, you're going to have 4s cubed plus 1 all over 3 plus 1 minus 7s squared plus 1 all over 2 plus 1 plus 5s raised to the power 1 plus 1 all over 1 plus 1 minus 6x plus constant. So this will give us 4s power 4 all over 4 minus 7s cubed all over 3 plus 5s squared all over 2 minus 6s plus c. Okay, to finalize this by simplifying it, 4 will cancel 4. We're going to have s power 4 minus 7s cubed all over 3 plus 5s squared all over 2 minus 6s plus c. So that is the final answer. Thank you for taking your time going through this video.